You. Okay, so when we talk expanding brackets, what we're going to do is examples like, let's sort this one out. So so we've got this expression, all right? Now, there's a couple of things. Not only do we need to be able to expand it, but we need to understand certain things.
It is recording.
Okay? This expression has two factors. Okay? So when you get to the next phase, which is factorizing, you need to understand what that means. So this is two factors. Now, do you know what I mean by factors? I hope you do.
Mm-hmm.
If I ask for the factors of 9, you would say 3, 1, 9. Okay? Because it's what multiplies. So this has got two factors at the moment. Right? You are told that one of the factors is 3. Okay? The other factor is x plus 6. So they are the two factors. They are the things that multiply together. Now, we have a form here, which I would call factorized form, because you know exactly what the two factors are. Okay? Does that make sense to you? All right? But when we expand, what we do is that multiplication. All right? So, for instance, 9 in factorized form could be 1 times 9, or 3 times 3. But then, when you unfactorize it, you do the multiplication and you end up with 9. Right? If I said a number is in factorized form, 3 times 4, the number is 12. We've got an algebraic expression here in factorized form, and it's 3 times x plus 6. All right? So we've got to figure out what it is as a complete expression without being factorized. Now, another thing I want to draw your attention to is this word, to simplify. All right? Now, I would need to make sure that you don't use this incorrectly. All right? So, when you simplify something, you have simplified fractions, you have simplified ratios recently, okay? What does it mean to simplify? Do you know? Luke?
Would it be like if it was 3 times x plus 6 and we knew what x was? Could we just like say 3 times?
I guess that would simplify. If I told you x, we would get the value for it. Yeah, that would be more simple. But let's say I haven't given you an x, right? But think back to fractions and ratios. What did simplifying mean?
Would it be to take out the brackets by looking?
No, forget this one at the moment, because it's what I'm trying to fight with fractions and ratio. What does to simplify it mean?
Like to find the lowest common multiple.
Okay, to find the lowest common multiple. But it's important when you simplify a fraction that you find the lowest common multiple, you divide through, but the fraction that you end up with must be the same fraction, yeah? An equivalent fraction. But you simplify it by taking that common factor out, right? Yes, Sushi?
Is this what we learned way back in like chapter 1?
Well, that was lowest common multiple with fractions and things. Yeah.
No,
but we did it with ratio last as well. So you take out the common factor, you simplify the ratio. Now, what I will say is, expanding brackets, okay, expanding brackets is not simplifying. Alright, that's why I'm giving it this word. I want you to think what simplify actually means. Alright, and to simplify means reduce the number of terms. Okay, now expanding brackets does not simplify unless after you've expanded brackets, you can then reduce the number of terms. Do you understand? So I don't want you to ever think of expanding brackets as simplification. It's not. All right? Equally, if we've got something that you then put back into brackets, it is not simplifying. A lot of people do that extra bit of work thinking that's simpler, but it's not. So expanding is not necessarily simplification. Make sense? All right, so we want to expand this, so we want to kind of write it as one number rather than as two factors, the factors being 3 times x plus 6. Does anyone already know how to do the expansion? Do she?
Do we write x plus 6 plus x plus 6 plus x plus 6?
You could actually. Yeah, we could write x
I
plus
learned that
6
as 5
plus
form.
x plus 6 plus x plus 6. That is, right?
What we learned
Now
in
that
three.
is more complicated, but can be simplified because we could simplify it by collecting everything together. And what could we do?
3x plus 18.
Yeah, 3x plus 18. Okay? So that's absolutely fine. That's a method to use. That is what we end up with. And that is what 3 times x plus 6 means. But what I would say is you will get to a point where you don't need to write it all out. But it actually helps us by saying, well, look, we've actually got 3 lots of x. And, so we do that multiplication. And we've got 3 lots of plus 6. Which makes plus 18. Alright? Now a lot of people forget to multiply the second number. But you can see from this line here that you have to multiply both bits. Alright? Make sense? So if I were to do 4 times a minus 2, and I ask you to expand it, what would you say?
4a plus 4 plus 8.
No. Not
Oh,
quite.
then it's minus.
Yeah. So what does it become?
It will be 4 times negative 2,
Yeah.
negative
Yes, exactly. So it would still be minus 8 there. Okay. What if I were to do minus 2 times 4 minus y? What do you reckon? Louis, what do you reckon? What do you think? It's definitely a hard one. Because this one doesn't really make sense with the writing it out like the x plus 6, does it? Like, how do you write minus 2 times? Minus 2 lots of anything. This is where maths gets a little bit more abstract. What do you reckon, Lou? So we do the same thing we've done before.
minus 2 times 4
Minus 2 times 4 is?
is minus 8,
Yeah, minus 8.
and minus 2 times y
Minus 2 times y, okay, is?
is minus 2y.
Minus 2y, but what are we missing? What are we missing? Your dad had her hand up ages ago.
The h should be plus 2y.
So it'd be plus 2y because it's minus 2 times minus y makes plus 2y. So that's where a lot of mistakes are made. So what I would like to point out is take each, this is a, part of the expression. Take the numbers and take their signs that go before them. Okay? That's a good way of remembering. So it's like positive 3 times positive x times positive 6. It's positive 4 times positive a, but times negative 2 and then it's -2 times +4 times -y. So you know about your positives and negatives, so you can work that out. Okay? Make sense?
I have a question.
You have a question, Susie? Yeah, go for it.
Meaning about the third question. Can we also write it as -8 minus 2y? Because
No.
that would be the same thing.
No.
Because -8 minus 2y will also
Yes, but
be
we don't write minus, do we? That would just be a bit messy and a bit, what would I call it? Amateur, if you like. Yeah? It'd be like saying, yeah, in my English essay, is it okay if I were to write and with the word with an M in the middle instead of an N? Because it's basically the same thing.
Yeah.
Yeah? So read it and. But you know what I mean. Yeah? No, I would actually say that you are now getting to the stage where no, we don't write negative, we write exactly what it simplifies to. Okay? Just one final one before I let you do a couple. I'm going to take 3 times 4x plus 6. Just one final example. Kian will do this one.
It would be 3 times 4x would make 12x
Yeah,
plus 18.
plus 18. Easy. Right, any issues with that with anyone? So you know how to do these things before. 3 times 4x is 12x. Okay? Now just think of where do people make mistakes. People make mistakes because they forget to do a negative times a negative makes positive, that's where they forget. They forget to do the timesing the number afterwards. Okay? Like this one, people are so focused on 3 times 4x is 12 and plus 6. That's what they do. Okay, so don't forget that. Okay? I will do one more, whether we get to that in the book or not, I don't know, but because you guys are smart. What about x times 4x minus 2y? Actually, I'm going to make it even harder. I'm going to make 2x times 4x minus 2y. Cammy, would you like to have a go at this one? I'll give you the 8. And you think it's 8x minus y plus.
Because it would be 2x minus
There's no, it's not a negative, so it won't be plus, it'll still be minus.
4y.
4y, you think. Okay. Put your hand up if you would have any adjustments to that. So Louis, no adjustment? You think that's right? That's what you would do? Or do you not care either way?
I'm not sure if it's right or not, but if it's not, I don't have.
You wouldn't have one. Okay. Daniel, what do you reckon?
Um,
No idea? Or do you agree? Do you think it's right? Or do you think it's right? Ben, what do you reckon? No idea?
I don't have an answer.
Don't have an answer. Do you think she's right?
Well,
Do you think she's wrong? Or you don't know if she's right or wrong?
I don't know.
What answer would you give? Would you give her answer?
Well, I would go, it's wrong, just joking.
Well, there you go. If you wouldn't give the same answer, you should have your hand up if you think it's wrong. Okay? You wouldn't give. Tristan, what about you? Would you give the same answer? Because basically, you either think she's right because you would, or you think she's wrong because you wouldn't give the same answer. You can't go with, well, I don't know, because I haven't thought of an answer myself. I want, come on, commit to something. No one on the fence here. What do you reckon?
probably wouldn't give the same answer.
You give a different answer. In what bit do you think's wrong?
It's the end bit.
The end bit. What do you think it would be?
Because it's either X or Y, so it's the one confused with that.
It should be an X or a Y. Okay.
Makes sense.
Like
What do you reckon, Izzy?
8x squared minus 4xy.
Yeah.
Ah, yes.
Xy.
Yeah.
What?
Okay, because it should be 2x times 4x is 2x times 4x, which is the same as 2 times x times 4 times x, so 8 and x squared. And then this will be 2x times minus 2y, which is the same as 2 times x times minus 2 times y. So you've got the minus 4 and you've got x times y. Okay? So they go together. Now that's one of the harder ones, but you do get it now, yeah? Okay. Sort of.
I wouldn't have thought of that, but I know.
Can we do
Yeah, I
one
would have done all that.
Okay, let's right. I will pick one from one question. Obviously, we're going to be finished in 1 minute. I would like you all to try this one then. This one, question 6, minus 4x times 2x plus 8.
Mm. Okay.